of laser and optical fiber. So in the last class I gave a very basic and crisp and short introduction to the chapter. Now, excuse me, I'll be starting with types of absorption and emission. Types of absorption and emission. So there is first, let's start with induced absorption. Okay, here absorption in the word itself, you should know that it is from lower energy to lower level to higher level. So it goes from E1, the the if when energy is provided, the particle goes from E1 to E2 when energy is provided. And how much energy? That delta E should be equal to E2 minus E1. Any random energy, the particle will not go from E1 to E2. That delta E minimum should be E2 minus E1. Electron has to receive minimum that delta E to go to the next state. And electron tends to stay in the ground state. That's why we have to excite it to make it go to the excited state. And here also it won't stay there permanently. The lifespan is only 10 to the power minus 8 seconds. Coming to the next one, which is spontaneous emission. Spontaneous emission. Absorption, that much only. Emission means it's coming from higher level to lower level. Higher to lower level, but the twist is that here no energy is provided. Here no energy is provided it by itself, because after induced absorption, electron is in the E2 state, right? Here we saw that the electron is in E2 state. It can't stay there because the lifespan of the electron is just 10 power minus 8 seconds. So it spontaneously comes down with emission of photon. While it's coming down, it emits one photon. Okay, there only one photon is emitted. Why am I specifying and stressing on one photon? You understand what I'm explaining. It's the mirror emission. Which is the next one. Here, one point we should remember is that in spontaneous, in the words of physics, it's very spontaneous. You don't have to force it or crib about it. Nothing. It's very spontaneous. Here, no energy, extra energy is provided. Next, the third type coming to stimulated emission. Stimulated emission. So here, what happens? Emission. That's why it's coming from E2 to E1, the particle. But here, the condition is that some certain energy is provided. I'm just giving an example of H, basically delta E equals to H, right? So basically delta E. Here what happens? Here also electrons in excited state only. The electron is supplied with energy, which is already present. The electron is already present in the excited state and providing it with energy. This results in emission of two photons. Here two photons are emitted. So for example, one electron, two photons are emitted. So for n electrons, two n sorry for two n, yeah, correct, two n photons are emitted. For one electron, two photons. So for n electrons, two n number of photons are emitted. Basically, the more number of photons emitted, the higher is the intensity of light. While explaining lasers, light amplification by stimulated emission of radiation, that is the full form of it. I said stimulated emission, photons are released, they group to form laser light. All that I have explained, right? So this stimulated emission is only used in laser. Now one more topic comes, that is optical feedback. What happens here is that for various various intensity of light is required. Suppose this is round one. Electron is coming from higher level energy level. It is just two photons, and this much is not enough for my work, for my procedure. What I'm doing, this much is not enough. So what I will do, I will input this as input energy. Okay, and this will excite more electrons. More energy is provided, so more electrons get excited. Right, more electrons get excited. So more electrons are from E1 to E2. Because more, and all these electrons are going to E2, and E2 lifespan is very less, so they have to come down. So while they're coming down, more photons are released. For one electron coming down, two photons are released. So imagine if more electrons go up, then double amount of photons will be released. So this desired purpose for desired intensity of light to increase the number of photons, we can do this. This is known as optical feedback. Now there is a derivation which I will be doing in the next video in part 3. So please check it out. Thank you.